All right, we're going to pick up here with video B, section 9.1. The previous video, we were just being introduced to significance tests, that they are based on a claim, and then we draw out a sample, and we look at the evidence provided in that sample to determine whether we want to reject the claim, which is the null hypothesis, or whether we are choosing to fail to reject the claim, which is the null hypothesis again. Okay. So we just finished in the previous video looking at how using what we call a p-value, which the p-value we had said back here represents the probability, assuming the null hypothesis is true. It's the likelihood that you would have gotten that statistic to take on that value or one that's more extreme. Okay, assuming the null hypothesis is true. And so what we do is we always compare that p-value to our significance level. If it is less than the significance level, that's when we're rejecting the null hypothesis. And if it's greater than the significance level, that's when we are failing to reject the null hypothesis. So we're going to practice a little bit writing some of these conclusions here. We're going to open with this example on Tasty Chips. It says, for his second semester project in AP Statistics, Zenon decided to investigate whether students at his school prefer name brand potato chips to generic potato chips. Now, he randomly selected 50 students and had each student try both types of chips in a random order. Overall, 32 of the 50, which is a p-hat, a sample proportion of 64%, students preferred the name brand chips. Zenon performed a significance test using the hypothesis that the true proportion of students who prefer the name brand chips, that's what we're told here, P is the true proportion of students at his school who are preferring the name brand chips. So our hypothesis is that half of the students prefer the name brand, and our alternative is that more than half are preferring the name brand. Okay, so the resulting p-value was 0.0239. You don't have to worry right now how he got that, but we're just going to practice right now using this p-value to help us draw the conclusion that Zenon should be making here. Okay, now one thing I just want to note here is when we said yesterday, or at least on the previous video, that the equal sign is always included on the null hypothesis, and what that equal sign indicates is that there is no difference in students' preferences between preferring the name brand chips over a generic chip. So if it's just 50-50, there's not really any difference between the two. Okay, so that's why that is set at an equal sign. Okay, now you can see in part A, the significance level, the alpha is set at a 5% level. And so we want to compare what side of 0.05 is our p-value of 0.0239 landing on. Okay, so we're going to set it up. This is always how our template is going to read. And on the next page, there is a template here for drawing your conclusions. But you want to say, since the p-value, which is 0.0239, is less than the alpha level of 0.05, anytime it's under the alpha level, this is when we reject the null hypothesis. Okay, and then we go on. If we've rejected the null hypothesis, that's when we have, we have convincing evidence that, okay, and now we want to cite what our parameter is. Right here where it says the true proportion of students at his school who prefer name brand chips. That's what we're writing. That the true population proportion of students preferring name brand chips is greater than 0.5. Okay? Anytime you talk about either having convincing evidence or not having convincing evidence, the evidence is always in favor of the alternative hypothesis. So you're ending your sentence always talking about the alternative hypothesis. So we're rejecting the null because we had evidence in favor of the alternative. Now on this next example here, you'll see that we changed the significance level to 0.01. And so now we're going to say, since the p-value, which is 0.0239, is greater than an alpha level of 0.01, we fail to reject the null hypothesis. Okay, so now we're going to say we do not have convincing evidence that, and again, what comes after the word that is us describing in words what our alternative hypothesis is, that the true population proportion of students preferring name brand chips is greater than 0.5. Okay, very important that we're always working in the context there of what proportion are we talking about? The proportion of students who are preferring the name brand chips. Okay, once again, just to reiterate this idea, an outcome that would rarely happen if your null hypothesis is true is very good evidence that your null hypothesis is not true. So that's why these times when we're saying that we're rejecting the null hypothesis is because the probability of it happening is very rare. It's falling less than our significance level. Okay? So it's very important that you are always setting your significance level before you run a test. It is considered unethical statistically to run a test, wait until you see the p-value, and based on your p-value, set what you want your significance level to be. That way your conclusion is going to be drawn, however you would want the results to be drawn. Always set the significance level before you have performed the significance test. Okay. One other thing just worth noting here is if your null hypothesis is something that is considered, to be widely true or accepted by a lot of people, and you're wanting to maybe show evidence against that, well, you might need really strong evidence in order to convince people or to kind of change people's minds. So as a result, you would need to pick an extremely low significance level, like 0.02 or 0.01, so that your p-value is extremely small. It has to fall underneath that alpha level in order to be really, really strong evidence to reject that widely favored, null hypothesis. This little chart here just kind of summarizes in different languages here, a small p-value means you're having evidence against the null hypothesis. It means it's very unlikely to have occurred if your null hypothesis were true, and as a result, we are choosing then to reject the null, versus a large p-value is not convincing evidence to reject it, meaning it could occur pretty frequently if the null hypothesis were true, and so we're just going to opt to fail to reject the null hypothesis. Okay, on the next page is a really awesome template that you can use to draft your conclusions for your significance tests. Basically, it depends on where your p-value lands in relation to what your alpha level is. If you are rejecting your null hypothesis, that is when we say our results are actually statistically significant. Okay, and the last thing that I'm just going to mention in regards to this interpretation for your conclusion is when we talk about having convincing evidence or not having convincing evidence, notice here it always ends with you stating the alternative hypothesis in context. Okay, so your evidence is either in favor of your alternative hypothesis, or you don't have the convincing evidence in favor of your alternative hypothesis. Okay, so let's look at this next example titled Better Batteries. It says a company has developed a new deluxe AAA battery that's supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce. So the company would like to be convinced that they really do last longer. based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. The company selects an SRS of 15 new batteries and uses them continuously until they're completely drained. A significance test is performed using these hypotheses. So the null hypothesis is that the true average lifespan of these batteries is 30 hours. The alternative is that they last longer than 30 hours. Okay? Now remember, the regular batteries are lasting 30. We're saying these new deluxe AAA batteries, they're supposed to last longer. And you can see here, lasting longer would be tied directly with me choosing to put a greater than symbol in my alternative hypothesis. Okay, now they are defining for us that the mu is the true mean lifetime of the new deluxe AAA batteries. Okay, and here is the resulting p-value, 0.0276. We are going to draw a conclusion at an alpha level of 0.05, and then what conclusion we would draw if the significance level were 0.01. Okay, we're just going to fill these blanks in, and you can look up above here. This is our template. We're going to be filling the blanks into the template here. This is how we want to draft every single conclusion to all of our significance tests. So we start by comparing what side of the alpha is the p-value landing on. So we're going to say since p equals 0.0276 is less than the alpha level of 0.05, we reject the null hypothesis. We have convincing evidence that, and then I want you to look back up here at the alternative hypothesis. And on this blank here, you're going to explain in words what that alternative hypothesis is suggesting. Now, you see the mu symbol here. We want to write out in context what that mu symbol means. So we want to say that the true mean lifespan or lifetime of the deluxe AAA batteries is greater than 30 hours. Okay, that's just stating the alternative hypothesis all out in words. Okay, if we were to do part B and change the significance level to 0.01, now we're going to say since the p-value of 0.0276 is greater than the alpha level of 0.01, now we're going to fail to reject the null hypothesis. Okay, since we're failing to reject it, that means we do not have convincing evidence that, and then again, what comes after the word that is you writing out the alternative hypothesis in words, that the true mean lifespan of the deluxe AAA batteries is greater than 30 hours. Okay. All right. Now, we're going to take a look at what are called type 1 and type 2 errors. And this is where things can get a little bit confusing, I think just because of the semantics of how these are worded. It mentions up here at the top, as is always the case in statistics, you could draw the wrong conclusion, okay? There is a margin of error here. Nothing is 100% certain. You can have a mistaken conclusion that you could make. We need to understand what mistakes can be made and the likelihood of making those. And so the two mistakes that can be made are titled a type 1 error and then a type 2 error. Now, we know there are two conclusions that you could draw from a significance test. One conclusion is to reject the null hypothesis, and the other conclusion is to fail to reject a null hypothesis. So let's say that we rejected a null hypothesis. That was the conclusion we made. We're going to reject the null hypothesis. Well, if we're wrong, what that means is we rejected a null hypothesis when in reality, that null hypothesis maybe was actually true. If that is the case, you have performed or committed what we would call a type 1 error. A type 1 error is when you reject the null, but the null was actually true. Okay? A type 2 error is when you fail to reject a null hypothesis, but, and I really like to word it like this, instead of saying the alternative was true, I say we failed to reject the null hypothesis when in reality the null hypothesis was actually false. Okay, so we didn't reject it, but we should have rejected it because it was false. That is called a type 2 error. Now, there is kind of a little tip here that they use to sort of help you remember this. You know, type 2, and you can think 2 F's here for type 2 error. 2 F's meaning a type 2 error is when your conclusion is that you fail to reject a null hypothesis, when in reality the null hypothesis was false. Okay, so kind of a double F there, I guess, if you will. Now, let's take a look at describing what a type 1 and a type 2 error might look in the context of a problem. Okay? So here we are back to this Ricky Bobby example from the previous video where he had claimed that he was an 80% free throw shooter, and we were thinking maybe you're not that good of a free throw shooter, and so our alternative hypothesis was that he was less than an 80% free throw shooter. Okay, we are asked to describe what would a type 1 error look like in this context, and what would a type 2 error look like in this context. So first of all, for type 1, okay, and I'm just going to be extremely generic, and then we'll add in the context here. A type 1 is when you reject a null hypothesis when a null hypothesis was really true. Okay, that is what a type 1 error is in its generic sense. Now, if we're going to write it out in this context here, what we're saying is we rejected this, but this was actually true. So let's say that in words here. We would conclude that he can't make 80% of his free throws, because we're rejecting that, when he actually is an 80% shooter. Okay? Because this is really the truth, but we were rejecting that. That is a type 1 error. A type 2 error, in its generic sense, is when you fail to reject a null hypothesis when the null hypothesis actually was false. So we should have rejected it, but we didn't. Okay, we didn't accept it, but we failed to reject it when we should have rejected it. Okay, so remember that 2 there, we think of 2 F's. You can kind of think of it like this: failing to reject a null hypothesis that was actually false. Okay, now what would that look like in the context of this problem? Okay, remember, we're not rejecting that he's an 80% free throw shooter, so I'm going to start it out like that. We don't reject that he's an 80% free throw shooter when, now look at what the truth is. The truth is he's not. He's not an 80% free throw shooter. The truth is he's actually this over here. He's actually less than an 80% free throw shooter when he is actually less than an 80% shooter. Okay, so I find when these problems ask you to describe a type 1 and type 2 error in context, I find it easier to write the generic version off to the side so I can see those 2 items there, and then I look at that and that helps me sort of put it into context over here. Okay, but this is what they really would be looking for, is this stuff here. If you just write these blanketed statements there, that's not saying what these errors are in the context of the problem. Okay, what you have at the bottom of this page here is just kind of a little chart or a little summary here, just to sort of help you keep straight type 1 and a type 2 error. Across the top, this is representing the truth, okay? So here we're saying the truth is the null hypothesis is actually true. That's what this column represents. But then along the side, we're saying over here, this would have been, though, the conclusion that you would have drawn. And so if we're saying the truth is that the null hypothesis is true, but then the conclusion that you draw is that you are rejecting that true null hypothesis, well, then you have committed what we call a type 1 error. Remember, we were rejecting the null, but the null was actually true. Okay. If the truth is that the alternative hypothesis is true, which this also, basically this column could be represented as the null hypothesis is false, okay? If the null is false, but your conclusion that you drew was to not reject the null, well, then you have committed a type 2 error. Okay, once again with the double F thing, failing to reject a null hypothesis that is false, that double F can help you remember type 2 has the 2 F's in it. Okay, and then this question down here asks, well, which of the two errors is generally a more severe error to make? A lot of times it does depend on the context of the problem, but just typically speaking, typically a type 1 error tends to be more severe. That's not always the case. You would want to look at the context of the problem and compare like what those would both look like in the context similar to what we have right here and kind of make your decision. But it generally is a type 1 error. Okay, so we're going to wrap this up with just this last page here. Says a significance test. I really like this connection here. It's very, very similar to how court systems work in theory, okay? For example, when someone goes to trial, a person is actually presumed innocent until there is enough evidence to prove whether they are guilty. Okay, so let's put this in a null and alternative hypothesis form. Okay, our null hypothesis would be that someone is innocent. And so we would begin the significance test, or we would begin the trial assuming that someone is innocent. Okay. The alternative is that the person is guilty. Okay. So the way this works in a government is they present evidence against the null. Okay. They're trying to show that this person is not innocent. Okay. They're not innocent. And they want to show evidence in favor of the alternative hypothesis, which is showing that the person is guilty. So what happens is the jury either rejects the null, so they say that they're not innocent, and they find in favor of the alternative, meaning they find the person guilty. Okay, that's rejecting the null and accepting the alternative. Now, if the government doesn't provide enough evidence against the null, then the jury fails to reject the null, and they find the person not guilty. Now, this is interesting here. Notice that they never say at the end of a trial that a person is innocent. That's never a conclusion, okay? And for that reason, we never accept the null hypothesis. Instead, we simply say, look, we don't have enough evidence to prove that they're guilty, so we're just going to say that they are not guilty, okay? They're not guilty. So in the context of the court system, we want to explain what a type 1 and a type 2 error are. Again, I'm going to start with just very generically writing what a type 1 error is. A type 1 is when you have concluded that you are rejecting the null hypothesis, when in reality, the null hypothesis is actually what is true. Okay? So if we are rejecting that someone is innocent, when in reality, okay, so if we're rejecting that, we're actually saying our conclusion is that then they're guilty. Okay, they are not innocent. So we're going to say they're guilty when in all actuality they were innocent. Okay, so we say that a person is not innocent when they actually are innocent. Okay, that feels like that is a pretty severe consequence, okay? We're going to go ahead and write what we think that consequence is. Well, I suppose if the court says they're not innocent when they really are, that would mean that you are going to punish an innocent person, okay? That feels pretty bad, that result. Okay, let's go ahead and see if we can draft what we think a type 2 error would look in the context of this court system problem. Okay, now this is when we would fail to reject a null hypothesis, but the null hypothesis is actually false. Okay, and again, there's with our double F right there. Okay, so we are not rejecting that they're innocent, but in all reality, they're not innocent. Okay, they're actually guilty. Okay, so we say that someone is not guilty when they actually are. Okay, feels like someone kind of got off scot-free here a little bit. Okay, let's talk about the consequence for this. Here would be the consequence. Essentially, we let a criminal go free. Okay, we're going to let a criminal go free. Now, the last part of this is asking, so which consequence do you think feels more severe? I mean, neither of those sound good at all, but it certainly feels worse to imprison or punish someone who is innocent. And so, for this, we might say that a type 1 error is worse because we're punishing someone who doesn't deserve it. Okay. Who doesn't deserve it. Okay, there are a few problems here for you to practice these concepts here, writing these conclusions and kind of talking about interpreting these type 1